Good afternoon, my students. Now we have learned about the what are the how will what are the different types of matrices, how the matrices will be formed, how will form a matrix by using the equations that we have learnt in the first session of this program. In the before this session, in that what we have learnt first is how we will find out a determinant of a matrix, and how will what is the determinant of a matrix, and how the inverse of a matrix, how we will find out inverse, and how we will find out this eigenvalues of a matrix. All these will be learned in the next session. So we will find out how the multiplication of a matrix, also we have find out how the addition of a matrix is two matrices, or you can say that the matrix will be multiplied with some other element. So how the multiplication will taken place, all this learned in the first session. And now we will find out some we'll solve the problems from question paper as well as in the our SAQs given in the blocks. So we'll take the class. So here first to continue with this the Cramer's rule. So by using Cramer's rule, we'll find out the determinant of a matrix. So first of all, this is the form of a matrix. In this we have to find out the determinant for this matrix. So here delta A, that we are finding 2 here for this element. So by taking these rows and this column, so we will find out we are having only these elements. So here 3 into 5 15 minus, so minus 2 into 1, so minus into minus plus, so 2 into 1 2, so this is, then again minus, and here the minus 1 is there, minus of minus 1 into, so here and this row here this column will be gone, and this row also will be not there. So we are having these two and these two elements. So in this 5 ones are 5, so 5 minus, and 2 ones are 2 and minus, so minus into minus plus, 2 ones are 2, again plus, then 3 we have to multiply with 3, and this row and this row and this column, so then again we have to multiply 2 into 1, so minus 2 and minus here this minus 2 6 minus 6. So here the determinant of this original matrix is 2 15 minus 2, what is 13, that is 13 minus into minus plus, so here what is 7 plus 2 plus 5, that is 7, then again here minus, so minus into plus minus, so 2 8 3 is 24. So here what, how much we are getting, this is 26 plus 4 7 33 minus 24, 30 minus 24, that is 13 9, only 9 only. So here the plus 9, this gives, this is the plus 9. So this is delta. Like that we have to find out for delta x also, for delta x, that is delta x, when just now I told you, when we are changing the finding the delta x, this you can say it x, y and z. So here at delta x we are finding, in the delta x place we have to replace these elements with these elements. So here how the equation will be formed, so 2 11 3 and then minus 1 3 minus 2, and the same 3 minus 1 5. For this we have to find out the determinant. So we will directly find out the determinant. 2 here the this row and this column. So here having only 5 are 15, 3 5 are 15, minus of minus and minus plus, so 2, that is minus of minus 1, the same, the minus 1 here will change. So here we are on 11 5s are 55 minus minus into minus, again it is plus 3, and the same like then next one, what you can say here 3, for 3 into, and this equation will be there. Here it is 11 2s are 22 minus 22 minus 3 3s are 9. So this is how much it is coming, 2 into 13, so minus minus plus 53 58, then plus no, it will come minus, so this is 31 31 3s are minus 3 1s are 3 3 3s are 9. So this is the total. How much you are getting? It is 26 plus 58, 26 and 58, that is 14, on this 84 minus 93, that is 84, sorry, 13 minus 9, so this is also we are getting 9. So the delta x also we are getting 9. So then here we will write delta is 9, delta x also 9, then we have to find out delta y and delta z. So then for delta y we have to change the equation. So we have to interchange the equation. So x equation will be like this only, 2 1 2, and second equation we have to replace with this one. So that is 2 11 3, and then 3 minus 1 5. So this is another equation. So for this also we have to find out the determinants. So delta y, that is 2, so we are these elements will be there, 11 5 is 55 minus into minus of 3 into minus 1, so plus 3, then minus into 2, it is 2, it is then this equation, so 5 into 1 5 minus into minus plus 2, so then plus 3, this equation 3 into 1 3, 2 11s are minus 22. So how much we are getting? So 58 into 2, 2 8s are 16, 1 2 5s are 10 11, this is minus 5 2 7 7 2s are 14, then here it is minus, so because minus is more, so how much it is, 19 3s are 3 9s are 27, 2 3 1s are 3 plus 5 57. So here this is the value, how much it is coming, 116 minus 170 71. So this is the value of the 5 and then 11, that is 4 45. So this is the value of a delta y 45, and then same we have to find out the delta z also. Delta z, that is we'll find out here, we'll replace with this column with this column. So here 2 1 2 minus 1 3 minus 2 3 minus 1 5. Oh, sorry, we have to replace with this 2 11 3. So this is the equation and find out the determinants. So for that 2 into this equation, so 3 3s are 9, minus here minus 2 minus into, so plus 22, then minus, no, minus into here okay, minus into minus 1 will get 3 minus 22, then plus 2 for this equation. So we are getting 2 minus 2 minus 6. So how much is the value? 22 is 9, so 31 plus 31 2s are 62. Minus, here minus into minus plus, again it is coming, no, it is minus is there, so again it is coming minus only. Here it is 22, so 19, that is 19, then here it is minus, so minus only, so 8 2s are 16, so that is equal to 62, that is how much it is coming, minus 15 1 35, that is equal to, what is 62 minus 35, that is 7 12 minus 5 7, and 5 minus 2 27, that is 27. The determinant of the delta y is 27. So like this we have find out the all the values of the determinants of all the matrices. So then we will find out the xy values. Okay, how much it is? Two. So these are the values. The formula for finding the x and y z, that is x is equal to delta x by delta. So what is the value of delta x? Here the delta x value is 9, and what is the value of delta? So 9, that is equal to 1. That means the x is equal to 1. Like that, here it is delta y by delta, that is equal to how much? The delta y, that is 45 divided by delta is 9, so that is equal to 9 5s are 45. The y value for the determinant of this equation is, the y value is 5. So like that, so delta, then z, we have to find out the delta z by delta, that gives, what is the delta z? So 27 upon delta is 9, so 9 3s are 27. So like this we have to find out the xy values of a equation. So this is the known as the Cramer's rule. In the Cramer's rule we will find out the xy values of the equation, or you can say determinant of the matrix. So in this way we have to find out the xy values by using the Cramer's rule. Okay. Then we will solve some the question paper of this June 2007 only. In this about I think 20 mark question is covered with this matrices. Total 7 questions will be given, and you have to write 5 questions you have to attempt. In this, one problem is given in the product, that is the multiplication of a matrix. It has given 2 matrices and find out the product of 2 matrices, that is A into B. Here it is given A comma B, 2 matrices are given, and we have to find out the AB, or you can say A into B. So this is already we have learned, or you can solve the problem. So we will go for solving this problem. Here the 2 matrices A, it is given minus 5 1 3 7 1 minus 5 1 minus 1 minus 1. this is the find the product. It has given find the product of two matrices. So two matrices are given. This is A and B. B is 1 1 2 3 2 1 2 1 3. This is the second matrix. So we have to find out the matrix, that is A into B only. Here again A into B, that is A B, that is equal to, only we are multiplying with these two matrices. You can say right A into B. So we have to multiply with total with this row with these columns as well as these columns as well as these columns. So we have to multiply all the columns with this. That is how we will multiply, we will find out. So the same multiplication is a simple one, the multiplying with this. So here what 5 ones are 5, that is minus 5, minus is given. So plus the 1 3s are 3 plus 3 2s are 6. This to find out this one element in the AB matrix. So this will give one element. Like that we have to find out all the three elements. So for like that, so we have to multiply this row with these columns. So we'll get the same. So minus 5 into 1. So 1 in plus 1 2s are 2 and 3 1s are plus 3. So like that again we have to multiply this row with again third column. So third column of B matrix. So like that here 5 2s are 10, that is minus 10 plus 1 1s are 1, that is 1 plus 3 3s are 9, that is 9. Again we have to find out the second element of the second the matrix of AB. So 7 1s are 7 plus same 1 3s are 3 and minus 5 into 2, so minus 5 into 2, that is minus 10. And same again we have to say multiply second row with second column. So 7 again 2 plus 1 2s are 2 and 5 minus, so minus 5 1s are 5. Again 1. Here we have to see the where the minus we have to here multiplying with minus into place, then we will get minus only. Like that, if that we have to concentrate. Otherwise the problem will be, the answer will be coming wrong. So that here we have to concentrate on this multiplying minus into plus or plus into minus. There we have to concentrate. So here the second element is coming, and then third element. So 7 2s are 14 plus 1 1s are 1, and then same minus 5 into 3, that is 15, that is 1. Again the third row with first column, that is 1 1s are 1 plus so here again finding the mistakes, the minus 1 into 3, that is minus 3 plus 1 2s are 2. Like that 1 which one, this into the second column. So 1 then minus 1 2s are 2, so 1 1s are 1 plus 1, that is 1, then 2, so again minus, so minus 1 plus 3. So like this we will find out the product of a matrix. So it is how much? It is 9 minus 5, that is 4, it is coming. Here also it is 0, here it is 0, here also it is coming 0, here it is coming, how much it is coming? 7 minus 2, so 4. So here it is coming 0, so here also it is coming 1 3, so 0, 3 it is also 0, here 3, 1 means 4. So this is the matrix of a product of a matrix, or you can write it as a 4. You can take back common from this equation, the matrix. So by taking 4 common, so 1 0 0 0 1 0 0 0 1. So what we got, sorry, just now while in the first class I have informed about this matrix. What we can call this matrix? This is the unit matrix or identity matrix. We can write it as identity matrix will be indicated as I, that is called 4I. So this is the in this way we can find out the matrix product of two matrices, product of two matrices. So in this is the problem. In this is the first problem, and then we go for the matrix of if A be the matrix, find the value of adjoint A into adjoint. So in the second, this is the A, first the question paper A, and then we'll go for the second question. Here in the second, that is B, what is if A B the matrix that is 1 2 3 3 2 1, that is 1 0 3, that is to find the value of here, find the value of A adjoint A. So by seeing this, how we will find out this A adjoint A? So by seeing the problem only, the students will be confused, but there is no, actually sometimes they can find out the adjoint doing this total solving A into A. You find out A and again finding of adjoint and then multiplying those two. So but most of the students have done like this only, the multiplying, but actually this problem can be solved in a different way. So here one has to know the problem of the A inverse, the A into, you can say that A transpose okay, suppose you can say adjoint A. First of all we have to know the formula of a adjoint A. Here here to solve this problem, instead of solving total multiplying with A into adjoint A, so here it is solved in simple way. Only thing we have to find out the A adjoint A. What is the value of A adjoint A? The find it is called find the value of A adjoint A. So to finding this, we have to know the formula, that is the A inverse formula, that is A inverse is equal to, this is the formula for the finding the A inverse matrix. So that is 1 upon A, determinant of A into adjoint A. So this formula we have to remember. So if you know this formula, then we will find out that is simply adjoint A. So by knowing this, what we will do, we are here only the A is required. So to find out adjoint A, so here only adjoint A is there, so A we need it. So for we will multiply in the both sides with A. So A is nothing but the matrix, so we will multiply with A in both sides, the value will be same. So that's why we are multiplying with A. So here if we multiply with A into A inverse, we will get A adjoint A by determinant A. So this equation we will get. So but we want only the adjoint A into adjoint A. The question has given it as find the value of A adjoint A. So here we got it. So what is the A adjoint A? Then A adjoint A is nothing but this, we have to take in this side. So we will get the value of A, then multiply with adjoint A into A inverse. So here this is A adjoint A, no, this is mod A, or you can say determinant of A, and this is inverse of A, inverse of matrix A. This is a matrix, this is the determinant of a matrix, multiplying, this is the determinant of a matrix, this is the inverse of a matrix. So here how will what you are understanding? Inverse, sometimes you can write, you can say that suppose it is given 3, or sometimes you can say 1 by 3 it is given. You can write it as in the inverse type. So if you can write it like this, 3 inverse 1. So like that, for this you can say this you can write as A determinant of A, but you can write here. So instead of write A inverse is nothing but A, no, 1 by A. So you can say 1 by A. So here we are writing instead of writing A inverse, we are writing A, 1 by A. So here A will be cancelled. That is the value of A adjoint A is nothing but determinant of A. I think you understand about the A adjoint A. The question it has given, find the value of A adjoint A. So A adjoint A is nothing but determinant of A. So we have to find out the determinant of this matrix. So how we will find out the determinant? So determinant of this matrix only, that is nothing but, so 1, so by taking this element, so this row will be cancelled and this row column will be cancelled. So we are having, so 3 2s are 6 minus 0 minus 2 for 2 this row, and this is 3 3s are 9, and here 1 minus 1, and then plus here 3 this column and this row, so cancels. Here 3 this is 0 minus 2. So how much you are getting? 6. Here 8 minus 16. Here it is minus 3 to the 6. So the answer is minus 16. The determinant of A. So what is the value of A adjoint A, that is equal to mod A, or you can say determinant of A, that is equal to minus 16. This is the value of A. This is the value of A adjoint A, that is minus 16. Like this we can find out the value of adjoint A. So again then we will go for the another problem, that is C in the question paper. Then C is find the rank of the matrix. So here the matrix is given 2 minus 1 1 1 1 1 minus 1 2 3 minus 4 1 0. So this is the order of 3 row and 4 column matrix. So 3 into 4 matrix, 4 order matrix. So by taking finding the rank of the matrix, here we have to find the determinant of a 3 by 3 matrix or 2 by 2 matrix. So by taking the determinant, so you can say we cannot say it is that the rank of the matrix is 4. So but here because it is a 3 into 4 matrix, so we have to take one 3 into 3 matrix. So first of all find out the determinant of 3 into 3 matrix, that is, so suppose you take these 3 elements here, 2 minus 1 1 1 1 minus 1 and 3 minus 1 1. So find out the determinant. So how much we are getting? 2 into this row, so 1 minus of minus plus, so minus 1, so let's okay, minus of minus 1, this is minus 1, this goes, then 1 minus, so minus of minus plus, plus 3 again plus this 1, that is 1 ones are minus 1 minus of 3. So how much we are getting? This is 0 and then minus minus plus, this is 4, here 4, 4, so minus 4, so this is also 0. So in the finding the rank of the matrix, so if it is the what we can say, determinant of a matrix is it is equal to 0. So the rank of the matrix is not equal to 3. So again we have to take the if it is equal it is what we are saying, it is equal to 0. The rank will be find out when the determinant of a matrix is not equal to 0. The rank will be given as, if it is the 3 by 3 order matrix, so the rank will be 3. But here it is not coming. So we will go for again we are taking this 2 by 2 order. So suppose you take 2 minus 1, then 1 1. If you take this, so a determinant will be 2 minus 1, no, minus 2 minus of minus plus 1. So determinant will be 3. So it is not equal to 0. Then we will say the rank of the matrix is equal to 2. So 2 by 2 order matrix, that's why we are calling the rank of the matrix is 2. But here in the 3 by 3 matrix it is coming 0. So that's why it is not, the rank of the this matrix is not equal to 3. So the rank of the matrix is equal to 2. This is the solution for the third question. Then we will go for the fourth question. The fourth question, here find the values of matrix. Here D, find the eigenvalues of a matrix. Find the eigenvalues of the matrix. Okay, that is the equation, the matrix is given, that is 7 2 2 minus 6 minus 1 2 6 2 minus 1. So here find how we will find out the eigenvalues. In the eigenvalues, what we will do, the characteristic one, everybody should know about the characteristic equation. That is the formula. How we will find out the characteristic equation? That is the standard formula. Characteristic equation, that is equal to you can say, suppose matrix is A, you can write lambda I equal to 0. This is the equation to find out the eigenvalues. So if any students doesn't know about this equation, then he could not able to find out the eigenvalues. So he must remember this formula. So this is the formula for finding the eigenvalues. So how we will find out for this equation eigenvalues? So here we will write this equation will be written as by using eigenvalues 7 minus lambda, only multiplying the diagonal matrices with lambda, subtracting. So by subtracting this 2 2 minus 1 minus 1 minus lambda, and how it is minus 1 minus lambda, 2 here 6 2 minus 1 minus lambda. This is the equation, that is equal to 0. That is the formula of a minus lambda I is equal to 0. This is the formula of finding the eigenvalues of a matrix. So in the how again we have to find out the determinant for the these matrices. So how will the determinant will be same? So mod a, that is equal to, how we will find out, the 7 minus lambda into, so this equation this row, this column and this will go, and only these two. So minus here bringing out how much it is getting, minus 1 plus lambda into minus 1 plus minus 1 plus lambda. There is nothing but we can write into multiplication only, plus this we can write it as 1 plus lambda whole square, this minus 2 2s are 4, okay, and then next minus 2 for this 2 into this will go minus 6 into minus 1 minus lambda, and then this is over minus, which one we are doing, these two, so this into this and this, minus 6 2s are 12, then plus for this 2 6 2s are, this row will be cancelled and this column will be cancelled. So by doing this 2 into 6 minus 12 minus into 6, so minus 6 into minus 1 minus lambda. So how you will find out here, this equation will be 7 minus lambda, this is 1 plus lambda whole square minus 2, and here you will find this is similar to this one, because 2, the plus 2 it is there, it is minus 2, and this is minus 6, so minus into plus, this we can say this is a similar one, here we will get 0. So we will total this equation and this equation will be cancelled, and only this equation will be there. So here this is equal to 0. So the one value for the 7 minus lambda is equal to 0, that is nothing but minus lambda is equal to minus 7, that is lambda is equal to 7. One value we got it, and then the another value for this is how we can say 1 plus this the whole square we are doing, lambda square plus 2 lambda minus 2, that is lambda square plus 2 lambda minus 1 is equal to 0. So this equation will be written as lambda square plus 1 there, so it is 2. So how we will write, we have to get the this 1 minute, 2 a square plus b square plus 2 lambda, b square means 2, okay, check है, 1 is 2, we can write lambda square plus, no, 1 1s are 1, so plus lambda, this 2 lambda we can write it as plus lambda minus 1, that is 0. So lambda we can take common, so lambda here lambda plus 1, and you take here it is minus 1, then we will get lambda plus 1, that is equal to 0. So for this lambda values are, lambda is equal to minus 1 and lambda is equal to 1, two values we will get, lambda is equal to 1 and minus 1. The total eigenvalues will be 1 comma minus 1 comma 7. These are the eigenvalues for this equation. So like this we can calculate the eigenvalues for this problem. So how we will find out? First of all, we should know about this equation. So what is that equation? That is characteristic. We will call it as a characteristic equation. In this, the matrices will be subtracted with lambda I. I is nothing but the identity matrix. So that's why in the identity matrix all the corners will be 1 1 1. So the remaining columns will be 0. So that's why we are getting this equation is in this form, that is equal to 0. So by solving the determinant we will find out the values. So this will be cancelled, and this equation we are getting here, the 1 plus lambda whole square we are doing. So that 1 plus lambda whole square is equal to how much it is getting. For lambda is we are equating equal to 0 here, 7 minus lambda, that is nothing but 7 is equal to 7, lambda is equal to 7. We are getting one value, eigenvalue, and another two eigenvalues will be solved by this equation. We will get lambda is equal to 1 and minus 1. This is the total eigenvalues will be minus 1, 1 and 7. So these are the how we will find out the eigenvalues for this problem. So like this, the another problems will be there. So for all, okay, like this. So how many problems we have solved? The 4 problems we have solved. So by solving these 4 problems, you will get 4 into 5 into 4, that is equal to 20 marks. So easily you can, by simply studying the matrices 1 unit, you will definitely get 20 marks easily. So you have to concentrate, my dear student, on the matrices, or I can give you how all our students will be may not get for doing all the problems, because our students are working in somewhere and they have to come and study in the house, and they have to look after their family and all these things. Apart from this, so the students can concentrate on which problems. So that I will tell you. One is the to pass, or you get instead of failing, once a student passes, he feels happy, and in the family also he feels happy. So that's for that I will tell you the matrices will help you in getting the good marks also, but scoring also. So first you study the mathematics to get the interest in the mathematics. So most of the students are coming to me, they are saying that sir, I am unable to pass in the mathematics. So every time I tell to the students, this mathematics is not a problem, because you simply pass in the mathematics. Instead of you go other subjects, they are having a critical, even though they are passing, but why mathematics they are not passing? The simple mathematics is there in our course, that is BME 001. So concentrate on this that is matrices. Matrices will help you to pass in your getting at least 20 marks. So you will get easily. And another scoring subject will be limits. Limits also you can do well, and then integration, differentiation and integration also please study well. By doing these 3 courses, that is matrices and differentiation and integration, you will definitely get about more than 40 marks, and if you study more you will get another marks. So students, you can with this I'll close my lecture. So today we have covered the matrices and determinants and eigenvalues and inverse of the matrix and determinant of a matrix and the multiplication of a matrix and subtraction of matrices, and first how we will form the matrix, that also we come to know in this session. Okay. Thank you, my dear students. With this topic I am closing today's lecture. Thank you very much for listening my lecture. Thank you very much.